We are able to offer programming at this time because of our wonderful members and our donors. So now I would like to introduce our speakers, Galen and Kelli. Galen was born in Clovis, New Mexico, and he graduated from high school there, and he has a PhD in astrophysics from the University of Cambridge. And he eventually came to Los Alamos, where he worked at the lab for 25 years. Then he and his wife, Susan, moved to Norway, where he learned not quite enough geology at the University of Oslo, finally retiring back to their cozy mountain home. The PEEC Planetarium is his favorite place to spend time. And Kelli Housley is a park ranger at the Valles Caldera National Preserve. She has worked for 8 different parks within the National Park Service, ranging from smaller park sites like Natural Bridges National Monument to more well-known parks like the Grand Canyon. She's been involved with astronomy programming for 5 years, but has been interested in the night sky since before her time in the Park Service. And she's excited to share her enthusiasm with you tonight. And I will attest that she's very enthusiastic about astronomy. So I'm really looking forward to her talk. Okay, so I think we start with Galen. So go ahead, share your screen.
Thank you, Joyce. It's a pleasure to once again be giving a night sky talk for PEEC, and I'm extremely pleased to be able to share this with Kelli Housley. This is part of a collaboration that PEEC and the Valles Caldera National Preserve have been undertaking over the last few months, and we hope that this continues. What I'm showing you right now is a screen from Carte du Ciel, which is a freeware astronomy program. I'll say a little bit more about it a little bit later on. And this is for the night of June the 12th. And the reason that I've chosen that night, that's a week from tomorrow, is because the Pajarito astronomers will be hosting a star party, a dark night at Overlook Park. So we encourage people to come. If you have telescopes, bring them. If you don't have telescopes, come and look through telescopes that others will bring. And we can, so I wanted to show, what will be available in the night sky for people who come looking to see things in telescopes. So just to orient yourself on the night sky, we're looking at the whole night sky from horizon to horizon. This is south, west, east, and north. Here, of course, is the Big Dipper with the pointer stars that point to Polaris, and the handle stars which arc down to Arcturus. Arcturus is the brightest star in the night these days. It's got a close rival over here in Vega, and then other bright stars that you might see at this time. This is about 11 o'clock a week from tomorrow. Are Spica in the constellation Virgo, and Antares in the constellation of Scorpio. And then we also have Regulus over here in the constellation Leo. So this is what the sky will look like after it gets fully dark. And of course, the summertime, it takes a long time for the sky to get fully dark. But I'm going to back up right now until just a little after sunset, when the sky is not, so 9 o'clock at night, the sun actually sets a little after 8. So at 9 o'clock, it's still not very dark at all. But I'm going to point us to the western horizon. I'm also going to turn on the constellation lines so that you can see them better. And I'm also going to turn on names. So what we have over here in the western sky at about 9 o'clock is Venus. That will be the brightest thing in the sky, and the first thing you'll be able to see as soon as it starts to get just a little bit dark. You also will probably see the moon, but it won't look like this. In fact, the moon will be a very thin crescent that evening. And so, so it might be a challenge to see it. So it'd be fun to go out, for example, to overlook for the Pajarito astronomer's dark night and look for the moon, very thin crescent, very close to Venus. What you might also want to look for at about the same time is Mars. And the moon is almost exactly between Venus and Mars that night. So it should be easy to spot. The two stars that are next to the moon are Pollux and Castor in the constellation Gemini. Gemini, of course, is usually, we refer to it usually as a winter constellation, but and it'll set, of course, shortly after sunset. I'm going to also draw on the ecliptic, which is the path that the planets, Venus, Moon, the Sun, Mars, all the planets follow in the course of their orbits. I'm going to point us back to the southern horizon. We still see Venus over here and the moon in the west. And I'm going to show what happens as the month wears on. So I'm going to move ahead by a day at a time. And I want you to watch how the moon goes and how Venus and Mars go. You'll see the moon advancing. It moves past Mars on the 13th. As the month goes on, it gets bigger and bigger. And Venus is coming along chasing Mars. Venus is moving faster than Mars, so we'll eventually catch up to it, but not during the course of this month. We'll see it catch up to Mars and pass it next month. And the moon, as we proceed through the month, gets closer and closer. It has passed the star Regulus. It has passed the star Spica. Both of these stars are well positioned close to the ecliptic, so they're frequently encountered by the moon. And on the 22nd, just a day after the solstice, the moon will be very close to Antares. We'll have a talk, I think 2 weeks from tonight, about the solstice. I think it's Akana Peck and Chick Keller who will be addressing the phenomena of the solstice, but if they don't mention it, you might mention to them to remark on the fact that the moon is very close to Antares on that night. It's very nearly full as well. I think it's like 96% full on the 22nd of the month. Let's back up to the 12th again, and we'll see this whole little chase play out in reverse. And you notice that that these three objects, Venus, Mars, and the moon, follow very closely along the ecliptic. And I'm going to stop at the point where moon is between Venus and Mars, which is the case on the 12th. Now what I'm going to do is advance time by an hour at a time so that we can see how the course of the single night develops on the 12th of June, a week from tomorrow. So it's we've set the time now for 9 o'clock, 2100 hours, and as we go into the night, it gets darker and darker, and the Cartesian program symbolizes that by changing the color of the background. And what you're also seeing, of course, is the whole sky, the stars in the whole sky moving from the east to the west, as is normal. Of course, that they're not moving. The Earth is moving. The Earth is rotating, and so it causes the appearance of stars rising in the east and setting in the west. And we all know this phenomenon from our daily lives. We'll go a little bit further. This is 1 o'clock in the morning, and you see the Milky Way now becoming very prominent in the sky. It'll be very prominent between 1 and 2 o'clock in the morning of these nights. But as the summer progresses, you'll see the Milky Way earlier and earlier in the evenings. And so we can look forward to seeing, the constellation of Scorpius and Sagittarius and all of the fantastic star clusters and nebulae that are associated with this part of the Milky Way, the densest part of the Milky Way. The other thing we're seeing is the summer triangle. I pointed out Vega a while ago, but then we have the stars Deneb in the constellation of Cygnus, the Swan, and Altair in the constellation of Aquila, the Eagle. These three stars make what is known as a summer triangle, which will become more and more prominent during the summer and will be with us until well into the fall. The other thing that's happening as we get into the early hours of the morning is that we see Saturn and Jupiter rising over here in the east. And we'll go a couple of hours further to 2 o'clock and then 3 o'clock in the morning. And there they are, extremely well placed for those of you who have the persistence to stay up until 3 o'clock and see them, or you can wait a few months and you'll see them in the evening sky. I think Kelli has some things to say about satellites of Saturn and Jupiter, so I'm going to stop my sharing and let her take over from here.
So as Galen said, Saturn and Jupiter right now are kind of the planets that you'll see if you really want to get up super early or stay up really late. By the end of the month, it'll be a little closer to midnight, and you can correct me on that time if I'm wrong, but won't be as ridiculous. But I know some people are really morning people and want to get up early and see these planets. So hopefully you'll be able to. This is a little bit closer than what you'll see them in the night sky this month. This is from last August. This is Jupiter and Saturn, very prominently placed in the sky. So the moons that I want to talk about, the moons of Jupiter and Saturn are kind of like miniature solar systems in and of themselves. There is such a lot of scientific interest and potential that it is really interesting to start looking at them a little bit more in depth, especially when we start looking at future missions that might go there. But also something really cool is that you can see them with binoculars or telescopes. I have seen the 4 Galilean moons around Jupiter a number of times. And with some of the moons of Saturn, I know it took me several observations of writing over and over again and not realizing I was repeating the same question of, is this Titan? Noticing this small little dot near Saturn. So if you don't immediately know their moons, that's okay. Just keep looking up towards the sky. I am not going to go super in depth with all of the moons though, because for just these 2 planets, we have over 150 moons combined. And I don't think you all particularly want to stay up until midnight with me to go over each one. But even just with the major moons that Jupiter and Saturn have, there are 11 combined. So when I say major moons, I'm mentioning ones that are large enough to have enough gravitational pull to make them spherical. So with Jupiter, that is going to be, as I mentioned, the 4 Galilean moons. So we've got Io, Europa, Ganymede, and Callisto, and that's the closest to Jupiter out to the furthest away from it. And then the 7 for Saturn, again, closest to furthest away. You've got Mimas, Enceladus, Tethys, Dione, Rhea, Titan, and Iapetus. So I'm going to touch on a few of them because they have some of them have some really interesting geologic features. I want to draw your attention to what Titan looks like right now, though, because that'll be important a little bit later. So last month, if any of you tuned in, I promised that I could talk about things that weren't just volcanoes, but I'm going to continue to talk about volcanoes. So I promise I can't talk about other things. Maybe we'll find out. But Io is this really cool moon, and I will start off by saying if I call them planets, that's totally my mistake. I noticed that I kept going back and calling them planets, so I mean moons. If I say planets, I apologize. But Io, as the closest moon to Jupiter, is a really, really active world. It's a really active planetary body. These black specks that you're seeing all over the moon are volcanoes, and the yellow coloring is sulfur. This is the most volcanically active body in the solar system. So here, this image from New Horizons that you see, this is a volcanic plume coming off of it. And the reason this is so volcanically active is that Jupiter has such a pull on the moon There's a really strong tidal force coming from Jupiter, but there are also other moons that are orbiting Jupiter and pulling on the other direction. So you've got tidal forces coming in every which way. So it's basically like a big tug of war, and it really messes with Io. Now, Galileo, when it was orbiting Jupiter during its mission, orbited several times past Io, and they noticed that there were new volcanoes that had formed and erupted just between those orbits. So it was clearly a very active world. Now, these volcanic plumes that you were seeing like in that image there, they can reach really, really high, a lot higher than any of the plumes from our planet. So around 200 miles high, compared to some of the really tall plumes on Earth that reach about 6 miles high. This is a really, really explosive world, pun intended. But this is, it is possible that there is a global magma ocean below the surface of Io. We're not certain on it, but it is very possible. It's just a very geologically interesting world. There are no impact craters that can be found on Io because of all of the volcanism that you see. The lava will immediately cover up anything that does impact this moon. And obviously you are not going to find any water or ice on this world because it is just too darn hot. But on the other hand, you have got Europa, which does have some volcanism in it, but it's a little bit different from what you see on Io. So the reddish brown that you see here, these are sulfur compounds that are either coming from the interior of the moon or from Io. As the volcanoes are exploding, it's kind of off-gassing into space and possibly landing on Europa. But what we have started to learn about Europa is that there very likely might be plate tectonics on this moon, except with ice instead of the crust that we see on Earth. So the reason that astronomers believe there are plate tectonics here is that when they were observing Europa, they were noticing that there were missing ice chunks that they had observed before. And there are also cryovolcanoes. So these are very similar to what we would imagine as volcanoes, just made of ice. So it's going to be a lot colder. It's not going to be exploding lava or anything like that. So the implication there is that there is subduction. So you can see in this illustration what likely is happening, or what we're believing is happening here. So this plate is going underneath as this plate is coming up to join it. Now, something really that we noticed using Hubble was that Europa had plumes coming out of it. They detected it in the UV radiation. And so the Galileo mission, those astronomers went back and looked through their data sets and found that those plumes were detectable in their data as well. So basically whatever was underneath this big ice shell was coming out and ejecting out of that ice shell off of the moon. And these are all images from Galileo itself. I don't remember precisely what the arrows are pointing at. Something exciting, I'm sure. But Europa is a really interesting one for those that are looking for extraterrestrial life. We always like to imagine green men on Mars, but what we are starting to understand is that if we are going to find life on another world, it is probably going to be either microbes, so something really, really small, or it's going to be life completely different from what we see on Earth. So the reason that potential for life is really high on Europa is you've got a lot of really good combination of environments, basically. So you've got a really stable environment. You've got this really strong ice shell that because it is so cold on this moon, the ice is as hard as granite. So this ice shell is protecting anything that might be in the ocean down here from that solar radiation. And we do know that there is a subsurface ocean under that ice shell. I don't know if I mentioned that. But the really interesting thing about Europa is that we can actually study it a lot easier than we could any of these other moons that seem like they have subsurface oceans and really thick ice shells as a covering because of these plumes that I mentioned. So Callisto and Ganymede, the other Jovian moons, they don't have anything ejecting from them. So if we wanted to study those oceans, we'd actually have to dig down underneath the ice. Whereas with Europa, we could get something that just flies by, essentially scoops up what's being ejected from the moon, and we could study that and see if there is life living underneath that ocean, or at least if there is that potential for it. So it's a really exciting prospect for future missions. Now, on the complete opposite side of expected life would be Titan. So this is the largest moon around Saturn. It's the second largest moon in our solar system overall after Ganymede. Now, Titan, this is the one that I said, remember what it looks like, thick atmosphere. When we just look at Titan, we just kind of see that orange. Its temperature is so cold that any liquid is actually going to be liquid methane on the surface. But that really low gravity of Titan and the really thick, dense atmosphere, so the atmosphere of Titan, means that it's really easy to fly on Titan, which is a mission copter, and we have recently potential for having Titan really high possibility. We have actually had a probe land on Titan. That was back in 2005. Quite a lot of orbits. I don't remember offhand how many, but they actually dropped a probe this is actually the first landing of a probe in the sun. This probe sent back data for 90 minutes before we stopped hearing from the surface. I really like images from the surfaces of other worlds. I think they're cool. But it's a really geologically active world as well, and it probably is the most Earth-like body in our solar system, simply because there are, and this is an artistic rendering, but there are rivers, there are lakes, sand dunes, mountains, volcanoes, cryovolcanoes, but still volcanoes on this world. It's going to be very different from Earth, though, because it is composed of different elements. So it's not going to be H2O water, it's going to be methane, ethane. And themselves, this is an image on Titan, and do a podcast about what Titan would smell like. I don't know if any of you have had the privilege of going to Sulphur Springs in Valles, Caldera, but you could probably imagine Titan would smell very similar to that scent, that rotten egg smell. I'm going to jump over to a couple other really interesting moons of Saturn. This is Iapetus, and notice you've got this really image of the moon and a really dark side of the moon. So half of the moon has this really dark side that is as dark as coal, and the bright side is like shiny ice. This was obvious even to Cassini, who was in this, and there was this really dark side that is as dark, might volcanic activity that we're unaware of, and that right here as well. You can see how it kind of rings the planetary as it shrank. That so that would explain why it's all right around. Explain why it's all right around Earth. At tectonics cracks that you see down here. Because again, we don't have to try to scoop this up and try to analyze it. Similar to your of life, and just in our neighborhood, just in our backyard.
Is this bad for you too?
Yeah.
This is
Saturn's moon. Mine just looks like the Death Star, and I like it. But it just kind of, I encourage you guys to go out and try to at least find them, even if you can't find like really good images of them, even if you're just wondering if it's just a little speck. That's Titan, that's Io or Ganymede, Callisto, because there's so much that we can find in our own backyard. And if we just look a little in the night sky, we can find some really intriguing and interesting things. So that is all I have. Galen, I will turn it back to you.
This is Joyce talking. I'm having audio difficulties as well. I'm not sure how to fix this. If anyone has a suggestion, you could let me know.
Thank you so much, Kelly. I hope people were able to hear part of it, and I know it was cutting out for me. But is my audio doing okay?
Galen, I can hear you now, and I could hear Kelly most of the time, just until the end. Some of the other participants are also saying they're having audio problems.
Right. Yeah. These platforms are imperfect, unfortunately, and there might be a lot of demand at certain times. Anyway, what I heard from Kelly was extremely interesting, and I would love to hear more about these moons. I know that Kelly's done a lot of research on this stuff, and of course, you know, she works at Kelly works at Valles Caldera National Preserve, which is, you know, right an enormous volcano, and so naturally she's sharing her interest in volcanoes with the rest of us, and enlightening us about the moons and so forth, and that's absolutely fascinating. What I wanted to do now for a little while is talk about some of the galaxies and star clusters that we can possibly see in the night sky these days, and in particular, if we go to the dark night at Overlook Park a week from tomorrow. Here are two galaxies in the constellation Leo. It's called the M96 group because M96 is one of them. They're really interesting barred spiral galaxies, 37 million light years away. These aren't the only galaxies in Leo. There's also this triplet of galaxies, M65, 66, and NGC 3628. And in a few minutes, I'll show you how to find these on the sky. The galaxies in Leo form these two little groups. The Leo 1 group and the Leo triplet are both together part of what is known as the Virgo supercluster. The main part of which is, of course, the Virgo cluster itself, centered on this galaxy M87, which we've heard a lot about lately because of the enormous black hole in the center of it that was imaged by the Event Horizon Telescope. And then also this really interesting chain of galaxies called Markarian's chain. Couple of Messier objects and then several NGC objects, and there are thousands more galaxies in the Virgo cluster. The Virgo supercluster contains the Virgo cluster, the galaxies in Leo. It also contains our local group of galaxies, our Milky Way, the Andromeda galaxy, the Magellanic Clouds, and several other galaxies. We're all part of the Virgo supercluster. So the Virgo supercluster is kind of the big mother cluster that we are all part of here. So I'll show you where to find these things, and then the other things that you can look at in the night sky next weekend are several globular clusters. These are much closer, of course, than those galaxies. Messier 3, very, very nice compact cluster. Messier 5, likewise. These are taken by the same person with the same equipment, so you can kind of compare them. And some people say if you've seen one globular cluster, you've seen them all. But actually, there are substantial differences. It takes an aficionado to recognize them. And then Messier 13, the great globular cluster in Hercules, which is even closer to us, and the brightest one in the northern sky. There are some brighter ones in the southern sky, but we'll show you where to find those in our night sky. Now let's see. Let me see if I can get back to Carte du Ciel. Oh, before I do that, I want to. Oh no, never mind. I think I can't do that. Okay, we're gonna look at this one. Okay, so here again is the night sky, the whole night sky, horizon to horizon, as it would appear on the 12th, a week from tomorrow night, at about 10 o'clock at night. So we see Leo here. It's easy to recognize the constellation Leo because of this bright star Regulus, which you can find by following the pointer stars in the Big Dipper, but instead of following them towards Polaris, follow them down in the opposite direction. You'll see Regulus. And from Regulus, you can draw a backwards question mark, which essentially defines the head and the mane of Leo. Now you look along Leo and you see a whole bunch of Messier numbers right down in here, and we will, let me see if I can center first on, yeah, that'll do, M95. Bring that to the center, there it is, and we'll come a little bit closer. So here again is the constellation Leo. It has a different orientation from what we saw before, but if you draw a line from Regulus to the second brightest star in the constellation, Denebula, that line passes very close to these two groups of galaxies. This is the Leo 1 group with M95 and M96 and a few others. And here is that Leo triplet, so-called, with M65 and 66, and that NGC number. So let's zoom in further towards the M95 group, and further, and now you can start to see the barred spirals that they are. I'll bring it a little bit closer together so you can see some of these other galaxies in that little group. We'll come back out to where we can see the full constellation Leo. Come over here to let's try to pick M65 or M66. That's okay. Center on that and zoom in. And there you can see that Leo triplet. It's a somewhat different orientation from the one that I showed you in the slide before, but it's clearly recognizable. M66, M65, NGC 3628, and there's a whole bunch more galaxies in this region of the sky. We'll go back out and then come over here to this very tight grouping of galaxies in the constellation Virgo. It's actually between the galaxies in Leo and the constellation of Virgo itself. We'll try to zoom in on M87. There it is. Come in close. And closer, and then suddenly Cartesiel populates this with hundreds of galaxies in the Virgo cluster. If you have a telescope or the opportunity of looking through a telescope, point it to M87 and just roam the telescope around, and literally you will see hundreds of galaxies. You may not be able to make them out, and in fact you have to use some tricks of vision, like looking slightly away in order to see them properly. But that's M87, which has an optical jet that was discovered in 1911 or by Heber Curtis. I think it was 1911, and then if any of you attended my talk 2 weeks ago, we talked about M87 as being a prototype of these giant double radio source galaxies powered by jets coming out of the black hole in the center of the nucleus. Here is Markarian's chain, M84, M86, and all these NGC numbers stretching out in this direction. That's just a small selection of the enormous number of galaxies that are in the Virgo cluster. Coming back out, let's look at Arcturus over here. Remember that was you find Arcturus. It's the brightest star in the night sky at the moment, and you find it by following the Handle stars from the Dipper, following that arc down to Arcturus. Arcturus is midway between a couple of prominent globular clusters, the ones that I showed you in the slide, M3 on this side and M5 on this side. And then we'll have M13 up here in Hercules. So let's look at each of these in turn. M3, center on, and zoom in. Globular clusters are enormously satisfying to look at through a telescope of 7 or 8 inch aperture, because you see them first as just a little fuzz ball, but then as you stare at them more and more, sometimes you're lucky enough, if the seeing is really good, to be able to pick out individual stars. And of course, there are hundreds of thousands of stars in clusters like these. Back up a little bit more. So, whoops. Yeah, so M3 is is to the west of Arcturus, and M5 is to the east. And we can center on that. And zoom in again. And again, we see this fuzzball which is made up of hundreds of thousands of stars. Come back out. And then Hercules. Hercules is, of course, a dominant figure in Greek mythology, but as a constellation goes, it's rather skimpy. The stars in it are not very bright at all, but on a good dark night, at a good dark site, you can make out this trapezoid. And if you follow the western leg of that trapezoid, about 2/3 of the way between those two stars is the brightest globular cluster in our northern sky, Messier number 13, and we can center it and zoom in, and again, hundreds of thousands of stars. And the picture that I showed you from Mount Lemmon is much better. This one from the Digital Sky Survey truly does not do it justice. But if you come out to the star party, the dark night on the 12th, be sure and ask, if you don't have a telescope yourself, to point at them. Be sure to ask one of the people with a telescope to point at M13 or M3 or M5 or any of these, or point to the galaxies in Virgo, and you'll be sure to get a treat. Let's go back to the southern sky. Another thing that that those of you with telescopes of 8-inch diameter or better might want to be interested in looking at is a quasar, 3C273, which is the most distant object that's accessible to amateur-sized telescopes at 2 billion light years away. It's also in the constellation Virgo, but it's faint, and therefore it's not very easy to find. Let me see. Yes. Okay. So here's Virgo. Here's the Virgo cluster. Here's Spica, and if you follow the line from Spica to this star, which is actually called Porrima, and follow that a little bit farther on, you'll land on 3C273. It's faint. It's like 12th or 13th magnitude, but as I said, it is accessible to amateur class telescopes. So if you get a thrill at looking at something whose light has been traveling for 2 billion years on its way to us, then that's your treat. If we'd had clear skies anytime this past week, I would have tried to find it myself in order to say that it can be done, but we didn't have clear skies. so I'm going to have to wait until the skies clear up to try it. But I'm kind of excited to do so, as well as to look. Once again, I've seen these things in previous summers. I'm anxious to have a look at them again. And I hope to see some of you at the dark night a week from tomorrow night. And we'll try to look together to see some of these things. With that, I'm going to put the sky back in full sky mode. Wanted to say a little bit about Carte du Ciel. I'm not associated with that program, but I enjoy it very much, and it's let's see, I can go back there. So we're looking here again at Messier 13. Carte du Ciel, it's French for sky chart, and if you go to this website, you'll see it advertised as sky chart. It was developed by some French folks, so the name Carte du Ciel has stuck. It's free. It's open source. It can operate on Linux, Mac OS, and Windows. It's got lots of very nice features. Stellarium is another sky chart that's free and available to people. There are lots of more expensive options too, like Sky Safari and Starry Night Pro and so forth. Those cost you hundreds of dollars, I think, to get the full versions. The Carte du Ciel is every bit as complete as any of those, and I've been using it myself for years and really like it a lot. It's the next best thing to being in the planetarium itself. And I actually say once again, if it hasn't been obvious, that that I really, really like being in the planetarium and being able to explore the sky myself there, where you get much more of a feeling of being surrounded by the sky. It's not quite the same as being under a good dark sky as we have access to it by Caldera, for example, or Bandelier, or some of the other dark places around us. But the planetarium doesn't have to worry about clouds, and you can make it as dark as you want, and you can also play with time in ways that you can't really do in real life. So with that, I'm going to close up, and I'll open for questions. Let's see, stop share. Yeah.
Hey, thank you so much, Kelli and Galen, for your wonderful presentations. I learned a lot, and I watch a lot of these, and I love those images of the moons. Those were just really interesting. Yeah, I want to call them planets too. I just want to go there and walk around and visit them. They're colorful and beautiful, and we've learned so much since I was a kid about what those look like on the surface, and it's just really amazing.
I know. When I was a kid, I remember Saturn had 9 moons and Jupiter had 12 moons.
That's
and that
right.
was it.
That's it.
Right.
We didn't know what they look like. And this is
right. And of
amazing.
course, we'd had no probes or anything. You know, all we saw was, you know, little dots in the telescope. That was it.
Right.
But now we're learning so much more about them, and it's so amazing. And it's amazing, Kelli, to be able to provide insights that we have from geology on Earth to these very exotic worlds.
Kelli, you're muted. If you'd like to unmute, then you can talk to us too. Okay. Yeah. I had a question. I'm waiting for some questions to come in on the chat, and I don't have any here, but I'm wondering, Kelli, if you were to have a space mission, a probe to one of those moons, which one would you pick and what would you do? And what would be your favorite?
That's a really good question, because I don't know if I know the answer to that. I personally was really excited. 2 days ago, NASA announced that they were sending missions to Venus in the next 2 years. So I'm really excited about that. I love Venus. I think it's really cool, and it doesn't get as much love as it deserves. But yeah, I don't, those moons, it's just, there's something about Enceladus. I don't know if it's because it has a fun name. I think that's cool. I think just the fact that it'd be close to Saturn's rings as well, kind of mixed in there. And just trying to understand, like, does it have plate tectonics? Is that the reason? The fact that they have a feature called tiger stripes is really cool to me as well. So I don't know, if I'm gonna have to pick one, I'll pick that one.
Yeah, I think after your talk, that was my favorite one too. Yeah. I don't have any questions in the chat, so don't be shy. Go ahead and ask. I don't know if I don't think your names get recorded if you put your name, you put a question in the chat. So don't feel afraid to ask a dumb question. There are no dumb questions, and I won't repeat your name anyway on the recording. So don't have to worry too much. Although I don't know, the names are up, the names are there, but who the question goes for is not going to be on the recording. So I still have no questions.
So I wanted to ask Kelli about Iapetus. That's the one with the dark half and the light half.
Yeah.
Is that tidally locked with Saturn, or is it?
I believe it is. Let me double check. Because I remember it being the leading side. My more in-depth notes on my computer.
So it's
yeah, it's tidally locked.
Yeah. So it's a leading side that is dark.
Yeah, leading side of the moon is a lot darker. It's called Cassini Regio, however you want to pronounce it.
So
that's the dark side.
So it's collecting stuff as it sweeps around somehow?
I don't know if they fully know why it's so dark. The notes that I have, and I don't have the more in-depth stuff that I got from this, but they were talking about a runaway heating system, but it is tidally locked to Saturn. So I don't know if there's a connection between the dark side and the heat versus the ice on the other side. I'm not certain.
Yeah, that's fascinating.
Yeah.
Mm.
No, I'm still waiting for questions. I have a question for Galen. That is it 3C273? That's the
Yeah.
quasar. What is its visual magnitude? What would I be challenged with to look at that in a telescope?
It's about 12th magnitude.
Okay.
So it'll be one of the fainter things that you can see in a 8-inch telescope. But it's there, and you can get a thrill of collecting on your retina light that has been traveling for 2 billion years. I mean, that's just that's just mind-boggling. Mm-hmm.
Yeah, 12 isn't as bad as I thought it would be. Yeah. Okay.
Okay. What can you see? What's
well, I don't have my own telescope, but when I would observe at McDonald, we would use a 15 or a 30-inch telescope or 36-inch telescope, and we would look at white dwarf stars that were 15th magnitude, and that was okay. We could do it with that big a telescope with a 15th magnitude. Yeah. I didn't have terrible problems finding them, but it wasn't easy though. Yeah. I think of 12th magnitude and brighter as bright. So, yeah.
Kelli,
okay, go ahead.
Okay.
We have a question. The question is, are there any multi-spectral data to determine compositions of the surface of planetary moons? Multi-spectral data.
I don't know on that one. That's a great question. Galen, do you know?
No, I mean, multispectral usually means, in the context that I've heard it in is when you fly something which has lots and lots of spectral bands and you fly it over. I don't know what the probes have had on them. You can get spectra of the moons, in telescopes with Hubble or whatever, but that's not the same as getting real multispectral data. I don't know what the probes have had in terms of that kind of capability. You would sure love to see multispectral or even hyperspectral data of them, because then you could start to determine already the molecular content of the plumes and things like that, which I gather we have not been able to determine so far. So and that's why they're talking about, I guess, scooping up stuff from the plumes with a low-flying probe.
Yeah, but I know it's hard because, like, a lot of times when we go there, if we're sending something like the probe from Cassini, when it went there, there were organic molecules that they weren't expecting to find in the atmosphere, so they were larger than their equipment could actually analyze. So they weren't able to actually figure out what they were. So there were assumptions, but it's like you have to kind of make the best assumption that you can about what the composition of it is like. It's kind of like with Venus, when we send the probes down, what will work, what won't work, we don't fully know because we don't have as much data as we want. And I think that's true for a lot of these moons, is that the focus has always been the planets and the moons are almost like secondary. So you saw with like Galileo and Cassini, they were orbiting the planets. So that was kind of the focus. And the moons just happen to be a happy byproduct.
Yeah, they flew by. Yeah. Mm-hmm.
So you see like images. Yeah, you see images of moons like of Uranus and Neptune that are only like, you can only see like 40% of the moon, because they just happen to get an image of part of the moon, but really the goal was the planet. Right. So yeah, the moons have not gotten, I think, as much love or attention as the planets, which is fair. We still, there's so much we don't have answered about the planets themselves, let alone the moons. So yeah, it's hard to know what questions to ask sometimes too.
So I have no questions in the queue right now. Galen, you had one that I interrupted before.
Yeah, well, I was, of course, all evening been advertising the Dark Night at Overlook Park for a week from Saturday, and I don't want to put Kelli on the spot, but in a way I do, about possibility of having Star Party at Valles Caldera. Is there anything that you can say on that now, or?
There's nothing I can say directly on that now. I will say that I am hopeful that will happen this summer. But as of right now, there are no scheduled in-person astronomy events right now. But we'll see if that changes.
Well, here's hoping.
I'll keep my fingers crossed too.
Yep. Right.
Well, this is the last call for questions. You can put them in the chat and they should come to me, but I don't see any. Well,
One thing that I want to say is that we will be starting to do Friday evening shows in the planetarium itself next month in July, and the current plan is that we will alternate. One Friday will be a Zoom show, as we're doing now, and that would be especially good for people who want to do, presentations with slides and stuff like that. And then one would be an in-person planetarium show where we can actually display things on the dome. So that's something that I'm very excited about. Can't wait to interact with people in the planetarium itself. That's something I've been missing for the last year and a half. So yeah, July.
yeah, that's actually was in my closing remarks here. So.
Okay, good.
Right, yeah, but I have a few more closing remarks. I wanted to thank both of you, Galen and Kelli, for sharing your knowledge and your enthusiasm with us tonight. And we do have a talk next week. Jeremy Best, who is the treasurer of the Pajarito Astronomers Club, will be talking about the history of astronomy. And it's a very family friendly program. It's not going to be at a really high level. It's a nice introduction. So if you have young persons in your household that would benefit from that, please sign up and invite them to come. And then, as Galen said, they'll be starting the programming in the planetarium in July, and we'll continue the Friday Zoom talks less frequently. So I've really enjoyed these Zoom talks. That I would have attended much fewer Friday things if it weren't for this. And I think many of our speakers would not have been able to do it, except Zoom has made it so easy for us to present. So I really like these. Okay, thank you both again for tuning in, and we'll hopefully see you next week. Okay, good night, everyone.
Good night. Thanks, Joyce. Good night, everybody.
Holly.
Thank you.
Good night, everyone.